So before I start on something new, is there any question regarding the lab session or laptop session that you had? So you see about the first model that he presented, although this was much general because it started in normal, but the results were all wrong, meaning economically they're not meaningful. So you cannot present a model like that because the first requirement is that the coefficients have to be all non-negative. Okay. So if you're running several models, among other things, you need to check those. Those are much more important than statistical significance. You cannot say that well, land has negative coefficients. It's not justified. Okay, whether it's significant or not, that's kind of a different issue. Okay. I might, again, depending on the situation, I might show some of the codes using etc. Okay, so since we talk about both input and output oriented model, and the focus so far was mostly on output oriented model. So the input oriented model, remember the main objective. I mean, if you remember the graph, we are going westward. Then we are thinking in terms of using less resources if possible. When we go to the frontier, we are thinking in terms of reducing the use of X. Okay? And X can be any of the inputs. So in one application, we used Indian banking. So we were thinking that whether banks are using labor optimally or they are overusing labor. Right? They are employing too many people in the bank. So what we did is we were talking about again like input-oriented methods because we are thinking in terms of possible reduction in labor without reducing output that banks are producing. So what happened is that when you are thinking in terms of input-oriented measures, it matches with what we call cost minimization. Because what you are doing is you are thinking of reducing your inputs given the output, and that is consistent with what we call cost minimization. If you remember the micro theory, okay, or again, micro, micro class, then we talk about cost minimization as again I will show you some graph that the objective of the form might be to minimize the use of resources to produce a given level of output. Okay, and that happens not to everything, but mostly for the service industry, because in service industry, if you think in terms of supply of electricity or water, okay, I mean they cannot produce as much as they want, right? Because what is the point of producing electricity when there is no demand, right? So this is what we call demand determined industries, and the service industries are like that. Okay, so let's say when you go to a hospital, the doctors are there, nurses are there, but there is no patient, right? So I mean, your objective should be that the number of patients is outside your control. The hospital cannot control. They cannot force you to go to the hospital and get treated, right? So there are cases, I mean this type of cases where output is exogenously determined. It's not in the control of the farm. But if you are making shoes or shirts or again producing other things, then it's your decision. I mean, if you are producing more than what is sold in the market, you can keep it for the next year, right? So again, so there are two types of situation. One where we are talking about service type industries, where outputs are exogenously determined, and then the other one is the regular case where output is going to be determined by the firm, again by maximizing profit or that type of thing. Right? So here again, I'm going to be talking about cost minimization. That means output is going to be exogenously given. So think in terms of again like a production function. I'll go through a little bit of algebra, but again this is not econometrics. Again, I'm assuming, as I mentioned before, that math is not a problem for you or should not be a problem for you. If you say it's a problem, I won't buy that. I will say no, you are not telling me the truth. Okay. So again, the production function, I'm just writing y equal to f of x and z. So z, again, you can include if you want to, or you can say that, well, f is a function of x only. So the way we distinguish often between x and z is that x is regular inputs and z is what we call sometimes facilitating inputs. Right? That means it's not directly inputs like capital lever and land and that type of thing, but it's kind of the environment. Right? So I think in terms of rainfall or temperature and that type of thing, they are not directly used in the production, but indirectly they help. If there is too much rainfall or there is not much rain, or if you have things like that, there is no sun, then again your output is going to be affected. But it's not like you can buy more sunshine or buy in a better weather, right? Which is the case for regular input. So this is how we often distinguish between an X and Z variable. Okay. So again, the point is that you have a technology which is given by this, and then your objective is to minimize cost. Okay, because remember, I'm just thinking in terms of service type industries. So you're minimizing cost, input cost, subject to the production function. So this is a constraint. And you know that when you are minimizing or maximizing a function with constraint, you have to define a Lagrangian, right? So you all know that. So this L is the Lagrangian, which I write W prime x. You have more than one x, and then plus lambda, that is multiplier, and then y minus f of x. Okay. So this is the function that you are minimizing, and FOC is the first order condition with respect to each of the x's, right? So jth x, you take a derivative of this with respect to xj, you get wj. And then from here, you get, again, like x is in here, so take a derivative of that with respect to x. You have lambda in front and your minus sign, so minus lambda and del f del xj. Okay. So that first order condition, it has to be equal to 0. Okay. So I forgot to put that here. So that's kind of the first order condition. Again, what it means is you can figure it out what is happening in here. That means the value of the marginal product is going to be equal to the price of the inputs. Now, since you have lambda, and lambda is something that we are not interested in, you can think of lambda as the nuisance parameter, right? You need to have that set up, but again, like yeah, we're not getting into it. There is no apparent meaning to it. So we need to get rid of that. How do we get rid of that? Well, take a ratio of this thing. So Wj over W1. So think of 1 as the first input as the numerator. Then you can do something like this. Wg over W1 is equal to lambda gets cancelled, Fg over F1. And again, what is this Fg over F1? Economically, this is what we call marginal rate of technical substitution between input j and 1. And this is the ratio of input prices. So again, in terms of graph, again, this is kind of standard micro. I mean, first year, micro class, we learned this. That means you have two inputs, x2 and x1, and this is the isopont. Okay. So the production function, instead of production function, we say, well, if you set y at a particular level, then it's a function of only x, and then you have two x's, x2 and x1. So you can have the isopont, which is associated with a particular level of output. Right? If output goes up, then again your isopont will move. Okay. And then again, you just look at the first order condition. So what is happening is the ratio of input prices is ratio of the marginal product, and that is given by the point of tangency. So the point of tangency, this slope is in terms of this, the ratio of the marginal product, and then again from the cost function, you get the ratio of input prices. So this equality has to hold, and this is given by the point of tangency between the isopont and the isocost line. So this is called isocost line. That means every point on this gives you exactly the same cost. Okay. So the question is that if you want to produce this much, what is the best way of producing? That's kind of given by the point of tangency. If you go to another point, something like this, you are producing the same level of output. But remember, that then line has to move, which means your cost is way higher. So that's not the optimal point. Optimal point is given by the point of tangents. So this is the graphical representation of this condition. Okay. So now going back to the math. So again, this is a ratio of two things. So J is running from 2 to big J because you are using 1 as the numerator. So how many equations are there? How many? So big J is the total number and J, little j is running from 2 to big J. So how many? J minus 1, right? So you have J minus 1 equations and the production function is another equation. So you have J equation to solve for J unknowns, which are the inputs. So you need to solve for the inputs. What is the optimal quantities of input? This is for x1, this is for x2. How do you figure it out mathematically? While you solve this equation, you have, if J is equal to 2, which is what is shown in the graph, then you have 1 in here because J is running from 2 to big J, which is 1, right? So one equation in here and one equation is given by the production function. So you solve those two equations to get your x1 and x2. These are going to be optimal quantities of x1 and x2. So this one you can just say out x1 star and this is x2 star. Okay. So these are optimal quantities of x1 and x2 that will give you the lowest possible cost to produce the level of output which is given by this right here. Okay. So again, without getting into this two input case, in general, you can just say that well, you have J minus 1 equations and this one is 1, so J equation or J x's, and implicitly you can say that well, the solution of those x's will be function of what? Function of everything else. What are everything else? If you look at it, everything else other than x is what? Y and in prices, right? So this is going to be a function of y and vector of input prices. Okay. So again, we call these things as conditional input demand function. Demand for each input is a function of how much output is being produced and prices of the other inputs. And I put the subscript J to indicate that well, you can figure out the demand function for each input. Okay. Now we can plug that optimal quantities and in the definition of cost. What is the definition of cost? Cost is sum of this cost of each input. So Wj times Xj. So this Xj is coming from here. Okay, it's a function of Y and W. So the cost is going to be a function of Y and W. So again, when you look at any textbook, okay, no matter what level you are looking at, you will see that cost is specified as a function of output and input prices. Now, most of the time, we just say, well, in a perfectly competitive market, input prices are exactly the same for every farm. If you believe in that, then again, this is a constant, so cost is a function of output. And that's what you see in a textbook. So you will see a graph like this. This is cost on this side and output on that side, and this is an increasing function of output, right? Because what is the rationale? Again, this is the marginal cost. That means if you want to produce more output, can you produce with the lower cost? Can you produce more with the lower cost? No, it's not possible, right? So if you want to produce more milk, then you have to increase your cost, right? And the cost is increased because you have to have more cattle or more of other things, right? So that now we're not getting into that. We are just saying that we solve for optimal quantities of those. So again, cost is a function of this output level and input prices. If input prices goes up, given everything else, your cost is going to be increasing. So the derivative of cost with respect to input prices will also be positive. Okay. So again, so this is coming from economics, or maybe that you consider what economics in here is the basic intuition. Again, you don't have to be a PhD to understand the implication of it. It's as simple as that. If in order to produce more, you have to pay. Your cost has to go up. Right? There is no way by which cost is going to be lower when you produce more. Okay. Okay. Any questions? Okay. So then there is something else in which you may not have what's called Schaeffer's lemma, meaning that well, if you take a derivative of the cost function with respect to input prices, you get your excess. That means input demand can be simply obtained by taking a derivative of the cost function with respect to input prices. And that is obvious if you follow the mathematics in here. That is, if you take a derivative of this with respect to input prices, you get your x because this is going to be equal to 0, the optimal with y equal to f of x. So this part is equal to 0. Right? So there are many different ways of looking at it. You can look at it purely from a mathematical point of view, or you can think of the mathematics combined with economic intuitions. Okay. So again, this name Schaeffer's lemma is used, but again, if you don't use the name, you can simply say the derivative of cost with respect to input process is going to be giving you the input demand. Therefore, if you take a log derivative, instead of looking at the derivative, if you take a log derivative, then this is going to be what? Log derivative is going to be like this is going to be what 1 over c del c del wj and then multiplied by wj. So you will be getting wj xj divided by c. And this is the regular derivative, this is the log derivative. Okay. And what is this? This is the cost share. So sometimes what we do is we specify the cost function in log terms, just like the production function. Remember we did a Cobb-Douglas production function, we can do a Cobb-Douglas cost function also. So that's going to be in log, so we'll be dealing with log derivative instead of regular derivative. Okay? And again, when you take a log derivative, that is going to be giving you the cost share. Okay? So this is kind of a backup, just to refresh your memory in terms of what goes on in a standard textbook, okay, about the cost function. Now we have not talked about inefficiency yet. So what I'm going to be doing is now bringing inefficiency into the picture. Right? So again, as I said, well, I could have gone straight in here, but I thought that let me briefly get to the rationale behind the cost function and then introduce this inefficiency. So now again, it will be repetition of what I did. Okay. So what is the production function with inefficiency? Remember, this is input-oriented inefficiency. So you are using x, but that's what less than, you are using 10 people, but it's what less than 10. It's maybe 8. So you have to adjust it for your inefficiency. So this is input-oriented inefficiency. E to the power minus eta is less than 1. So this is kind of the factor that is scaling it down, and we are assuming that to be proportional to all variables. So x is a vector, but again, this is a scalar. That means you can think in terms of scaling it down by the same proportion. Okay, so now again, write down the first order condition. So what is the difference between this and the one that I showed you? Okay, so this was y equal to f of x, and this time you have y equal to f of x times this. So in your mind, this is what I always tell people, that if you have difficulty in following the math, keep a picture of the previous one in your mind, and you say what is the difference between what you saw before and now. The difference is that well, whenever you saw x before, you just think in terms of x times e to the power minus zero. So this is kind of input adjusted for inefficiency. You need to say something? Okay.
This meeting is being recorded.
Okay. So if you write down the first order condition, it's going to be exactly the same. The argument is not going to be x, but x times e to the power eta. As I said, you keep your that type of changes in your mind, and the right hand side is going to be the ratio of input prices. So the point is that if you replace x before by x times e to the power minus eta, then these two things are exactly the same, right? You don't have to do any extra math, because you said, I have already done it, and then you just replace x by x times e to the power eta, and then you'll be getting your cost function for inefficiency. So then again, the cost function with inefficiency is going to be defined in this way. Okay. So this is w times x times e to the power minus eta, because this is the cost of inputs adjusted for inefficiency. So you're not talking about 10 people, but you are talking about 8 people, right? So this is again a construct. This is not actual cost. Actual cost is going to be Wj times Xj, and this is the minimum cost, right? The minimum cost is obtained by multiplying this efficiency adjusted inputs by their respective price. So this is not what you see in the data. Okay, so what do you see? Then you have to relate this to actual cost, because this is not something observed. And what is actual cost? Actual cost is cost of input. So what is CA? So this is equal to summation of Wj Xj. So we have to show the link between, sorry about the handwriting in here. So what we have to do is we have to show how actual cost is related to the optimal cost. Now again, like there are a few lines of math, but think in terms of this. Because of inefficiency, every input is increased by 10%, for example. So can you tell me by how much cost is going to be increased? Every input is used by 10% more. So by how much cost is going to be increased? 10%, right? So as simple as that. So again, here I have few lines of math, but in the end, what you get is like this. Okay. So in the end, sorry, in the end, you get actual cost is minimum cost plus eta, because eta is telling you by how much the inputs are increased, and therefore cost is going to be increased by the same proportion. So log of actual cost is log of the minimum cost plus this input oriented inefficiency. Right? And then I added B in here because again we need to add a noise term to estimate the model econometrically. Okay. So then again, like you can define cost efficiency in this way. That means your minimum cost divided by actual cost, so that the number is again between 0 and 1. Okay. So again, this is the minimum cost. Your actual cost can never be less than the minimum cost. It's going to be always bigger or at most equal to. So this ratio is going to be again between 0 and 1. So this is consistent with technical efficiency or output-oriented efficiency. Okay. Alternatively, you can just say that, well, what is the meaning of that? So if you take this minus 1, so that is approximately equal to eta. That means it's just showing that the percentage increase in cost because of inefficiency. And again, I give you the intuition that if every input is increased by a certain percentage because of inefficiency, cost is going to be increased by exactly the same percentage. So this is what is happening. Okay, after doing all the math, it's just, well, this is obvious, right? And that's what it is. Okay. Okay. So now the question is, okay, how do you specify this econometrically? Because you have to estimate it. We are interested in estimating the parameters associated with the cost function, the minimum cost function, and we are also interested in estimating cost inefficiency. That means the percentage increase in cost because of inefficiency. So what you do is, again, here I have a task log specification, but never mind with that. So this is the minimum cost, and we are specifying a function for that. So let me just do something like this. Okay, if I cross out this part, so let's just get rid of this. Then again, what is it? This is a Cobb-Douglas cost function. What is Cobb-Douglas? Cobb-Douglas is a log linear function of the arguments. Right? In a production function, arguments are inputs. So when you take a log linear, then log of y is equal to, again, a linear function of log of x's. Right? So here again, it's a log linear, and the arguments for the cost function are w and y. So you take a linear function of this with a log of y and a log of w. You have a single output y, so this is the coefficient, and these are the coefficients of the input variables. Okay. Now there is a couple of things for a cost function. Okay, well, you don't need this thing. I mean, because I cross out the other terms. So what happens is there are cost function which is the homogeneous of degree one. So again, what is the meaning of homogeneous of degree one? Again, you may have seen a function is defined as homogeneous of degree one if you increase the right hand side by lambda, left hand side will increase by lambda. Okay. Now, why cost function is homogeneous of degree one? Okay. So, what is the definition of cost? So, the definition of cost is what did I write? Okay. So this. So, if the prices go up by lambda, what will happen to cost?
Increase by lambda.
Increased by lambda. So this is not an assumption. This is kind of a definition of cost, right? So do not try to say that well, this is kind of I'm imposing a restriction for the cost function to be homogeneous of degree one. It has to be satisfied, okay? Because it's coming from the definition of cost, okay? So again, if it is homogeneous of degree one, then again there will be some constraint imposed on that, and that is basically sum of the beta j's is going to be equal to one. That's kind of if you restrict this, then it will be automatically. The function is going to be homogeneous of degree one. So one easy way of doing it is divide your cost by one of the input prices, and on the right hand side, your input prices are going to be also divided by the same one. So that way you don't have to worry about imposing it separately. You normalize your cost, okay, with respect to one input price, and also the other input prices again normalized by that. Which one doesn't matter, okay? So if you have 5 inputs, use any one of those, price of any one of those, and normalize both the cost and other input prices. So that price is not appearing directly, okay? So this is a function of, see that why I put tilde in there, and tilde is defined as the ratio of that. So W1 is out of the picture, okay? Now since W1 is out of the picture, you are not able to get beta 1, right? But what is, if sum of the beta is equal to 1, then what is beta 1? It's 1 minus sum of the other betas, right? So you are not losing anything. You are able to recover all the parameters, okay? Even though you just write it out like this. Okay. So in the end, what happens is, let me just write that down. Creating a page in here. So what is happening is, if it is a Cobb-Douglas cost function, so you are writing it out like this: log of actual cost, okay, is a linear function. So let me just write beta 0 plus beta y log of y. Okay, and again this is normalized, so let me just do it like this so that you don't get confused. And then again like beta j, okay, sum of beta j is equal to 2, not from 1 to big J, and then log of wj over w. Now even if you put j equal to 1, what will happen? W1 divided by W1, which is 1, right? What is log of 1? Log of 1 is 0, right? So again, if you fail to put that in, it's automatically going to be equal to 0. But, okay, and then again you are going to get eta, and then plus V. So again, V is noise, which is ad hoc, and again this is input-oriented inefficiency. So now if I ask you, do you see any similarity between the production function and the cost function? Or dissimilarity? Mathematically speaking, what is the difference between a production function? Let me write it like this. Production function is like this. Okay, so let me just write the different notation. Okay, alpha j log of xj plus v minus q. So I'm just putting them side by side. Now again, don't try and argue that well this is y and this is x. No, you just think in terms of mathematics. These are notations. So forget about whether it's x or y or w. Now think in terms of again variable. So when you look at these two side by side, okay, what is the difference that you see? On the right hand side, you have some variables. In here, we have also some variables. Right? The variables are different, but again, as I said, well, that is not the point. Okay. So then again, what is the difference? You have V, right? What is that? Here you have theta and here you have minus. So this is positive and this is also positive. So what is happening? You have plus sign in here and you have minus sign. Okay. So that is the only difference. So remember, he was saying that well, orientation, okay, and then you have to put O in there, output oriented. Now, if you want to estimate a cost function, then you have to change the orientation, okay. Now, this is the package. He was using SF cross. Now, if you don't use SF cross, but again, like some other command to estimate it, one is by default. Output oriented is by default. If you want input oriented, then you have to say that is a cost function. So they specify it as a cost function versus production function. For a production function is negative, for a cost function is positive. Right? So do you need a separate program? No. I mean, it's exactly the same, right? The only difference is the sign. But if you think in terms of pure mathematics, mathematical point of view, you should blindly follow this, then how do I get from here to there? Well, multiply everything by -1. So then again, like, v will be minus v and e will be plus e, right? And v is symmetric. So plus v or minus v, right? If something is symmetric, the sign in front of it is symmetric. Right? So another way of saying is that well, if you have only one program, right? That means output-oriented measure. You can still estimate a cost function. All you have to do is every variable has to be multiplied by -1. Okay, and then when you get the parameters, you have to also multiply by -1 just to see that well because you multiplied the variables by -1. But again, you don't have to do it. But I'm just saying that like mechanically speaking, one program is enough, right? But I mean. It is still one in a way that you have to specify the orientation. Okay. So again, as I said, well, you don't need to know anything new. There is nothing new in cost function estimation. You go to the same program, and then again, if you are using SF cross, then you have changed the orientation from output to inputs, right? Okay. So, but again, like in terms of data to estimate input-oriented inefficiency, the data is completely different. Right? In a production function, you are using data on output quantities, output quantity, and input quantities. Now, these data are readily available for most of the cases. Right? Now, when you estimate a cost function, remember you have to get data on cost. Now, that is not probably that difficult because this is the total cost of variable inputs. Yeah? And then again, this output, which is probably not difficult to get. The difficulty is in here, getting input prices. Now, most of the cases you don't get input prices, or even if there are, you get the information on input prices, there may not be much variation. Okay. So if you are looking at price of fertilizer, and I ask all the farmers in Haryana that well, what is the price of fertilizer that you use? Think of a particular type of fertilizer. Probably everybody will be saying that price is exactly the same. There might be a little variation here and there, depending on where you bought it, whether you bought it in this town or the next town or somewhere where you can get a better deal. But again, these are very minor variations. And in econometric estimation, what happens is that you have to have variation on the independent variables. If there is no variation or very little variation in the independent variable, your estimates are not going to be good. What do we mean by that? That means you won't be able to, you can draw a line. So if I give you points like this, okay, so if I give you a bunch of points like this, and say that, well, you fit a line, you will be fitting a line, but you are not going to be very comfortable with that. Because again, if I add one data point, you might be saying that, okay, the line saves. Okay. But if there are points like this everywhere, then again, you have much better confidence in saying that, okay, the feed is robust. It's not going to be changed if I take out one point. So again, the variation in independent variable is essential for a good estimation of econometric model. So the cost function has this problem if you don't see enough variation in prices. Now, again, if you come to think about it, that why should there be variation in input prices if you think that market is competitive? So it's kind of contradictory. Sometimes we just say, well, okay, price of the input should not be varying much. Okay, it depends on how you measure it. Sometimes we use labor as the number of heads, number of people. But if you look at the university, for example, in here, and then look at how many people are working, and that includes the vice chancellor as well as the people who are cleaning the floors, right? So then again, if you ask that how many employees are in there, they will say that well, there are 5,000 people working. So you get the 5,000 number. But again, now if thinking in terms of quality, is there any quality difference? Of course, the sweeper, I don't know how much he gets, and then again, I have no idea how much the vice chancellor gets, right? So there will be a factor of maybe 100 or 1,000, I don't know, for the salary of vice chancellor. But again, so looking at the number of people working, that's a very bad, so what happens is that instead of looking at number of people working, you might be looking at the cost of labor. Because the vice chancellor, if he gets 1,000 more than a sweeper, then again, like vice chancellor is one, and then again you get multiplied by 10,000 to make it comparable to the sweeper, or divided by 10,000. So this is going to be adjusted for. So very few times we do it because we don't know the salary. For example, I don't know the salary of the vice chancellor. I don't know the salary of the sweeper. But again, I have information about the number of people. So they just use number of people. The same thing for banks. So we did a study, I told you that was on Indian banks. But the good thing is that at least in India, for banks, we have the data is reported like class 1, class 2, class 3, class 4. Right? So again, I don't know which way it goes. Class 4 employees are the sweepers or clerk and that type of people. So we have, for each bank, we have data on how many people are in each category. So then when we are going that one, we can control for quality of the inputs by looking at those type of classifications. But let's say you go to US and banking data there is freely available. You can go to Chicago Fed and download the banking data from there. Okay, it's free, but again, like, they don't have this type of information. Of course, in the US, they don't have this class 1, class 2, class 3, class 4, but they also have it because everybody is not getting the same salary. The people who are working as a tailor, they get a lot less than the manager, okay, or the CEO, for example, meaning the president of the bank. So this quality variation is there, and again, they report number of people working in each bank. They also report the cost. But unfortunately, most of the people use the quantity data and they don't control for the quality. Okay. I so that, but again, like you know that should be the case because it does not make much of a difference to equate vice chancellor with the sweeper. Okay. But again, if you have that data on the and that's available because if you know how many people are working, they will be also reporting what is the labor cost, what is the cost of material, what is the cost of those things. So you can replace your X again in the production function, replace X by instead of the physical quantities, you can just look at the values or the cost of those things. So I think that's the kind of a better measure than looking at simply the number of people working. Okay. So anyway, so this is the point I wanted to make. So that means you don't need to do anything extra in terms of estimation. You just change the sign from minus to plus, and that's going to be interpreted as input-oriented inefficiency. And then again, the interpretation of that is the percentage increase in cost because of the fact that you are not allocating your inputs efficiently. Okay. Now again, like given when I will finish in 5 minutes. So what is happening is now let's just show you another picture. When I did the first order condition, I was looking at the so I think these are distributed to you. Um, okay, so again, like in the last session, you was talking about allocative inefficiency, which we have not mentioned. So we are focusing on technical inefficiency. And again, there is a reason why we call it technical, because it's coming from the technology. There is no economics in there, right? Technology is technology. If you talk to an engineer, he or she will understand what a technology is. Technology of production of electricity, technology of production of anything. So this is again a concept that has no connection with economics. Right? So again, when you talk about cost minimization, then economics comes in because we are using a particular behavior, and the behavior is to minimize cost. That means you are using the inputs in a way that will minimize cost, and you are using the production function, right? In doing so. So then again, we go from non-economics to economics by estimating the production function because a particular economic behavior is built in. But in doing so, we were assuming that there is no misallocation. Okay, that means like allocation is exact. Let me just see whether I have a graph. No. Okay, so what do you mean by misallocation? That means the first order condition is not exactly satisfied. That means when I was drawing the graph, I had this isoquant, and then I was looking at a point of tangency, right? And I said, well, this is the optimal point. And I was assuming that everybody is doing that. Nobody is making a mistake. But what happens if somebody is making a mistake and again, instead of the optimal point, they are to the left or to the right of that? So what is happening? Because you are not using the optimal point, the cost of this point is going to be higher because I have to draw in the line that goes through this point. And this line is about this solid line. And this solid line is indicating the cost, okay, and the dotted line is going to be indicating a cost which is going to be higher because it's associated with again like even the price again you will see that well this has a higher cost. Okay, so then again the way we say that if you do not use the inputs optimally, you have suboptimal allocation, that will increase your cost. So that is going to be your cost of allocative inefficiency. Right? So far we have not mentioned it. And there is a particular reason for doing that, is complexity. As soon as we bring allocative inefficiency, things get mathematically complicated and also econometrically complicated. Okay? So the way we do is, we just said, well, if it is not equal, then you can make them equal. When something is not equal, you can always make them equal by doing some adjustment. So what is the adjustment? So I can say that what Fj over F1 equal to Wj over W1 times something else. So what is this? This can be bigger or smaller, right? So that means what is this epsilon j? It can be positive or negative. So if it is positive, e to the power positive number is what? Bigger than 1. E to the power a negative number is less than 1. But they're all positive, right? So again, depending on the sign of epsilon j, it can be, you can move to a point to the left of the optimal point or to the right of the optimal point. So the misallocation can be captured by this term eta j. Okay. And then you go through the same type of thing. And if you do the profit maximization, again, you do not equal marginal product to the ratio of input prices normalized by output price, and again you can do the same thing. Okay. So now again, like the question is that this is kind of the model in of the graph. Now, how can you express it mathematically, and then from there you can go to parametrics. So this one is where we introduce allocative inefficiency. Since the production function is going to be expressed in terms of log, let's just think in terms of taking a derivative in terms of log, not in terms of the level. So when you do that, then this condition can be written like this. Okay, just simple algebra. Okay, and again, like this is again log of s of j. This is the factors here minus log of again s of 1, and this is again if you take a log after so again this is log of wg over w1. This is beta plus log of xg over x1, and then plus epsilon j. Okay. So now, what is happening is, if it is a Cobb-Douglas, then this is going to be equal to the constant beta j or alpha j, depending on how you specify it. So let's just say this alpha j is the parameter in here, and alpha 1 is the parameter for that. So this is really simple, and you estimate this along with the production function. Okay, so the complicating part is that so far this part was introduced 30 years ago, at least 30 years ago. But there is no program that will help you to estimate this thing. So this is kind of a, because everybody is afraid of writing down codes that will do the estimation, not one equation but as a system. So this is what is happening. Okay. So again, to cut it short, so this is how it's done. And then again, we have the program. So if you go to the website of Gian, one of my co-author for the book, second book, not the first one, then you will be able to see that he has the SCADA codes in his website. So you can download the SCADA code free to estimate this type of model. So remember at the end, the very end, we were talking about we are interested in the cost, by how much the cost is increased because of misallocation or allocative inefficiency. So it's not only technical inefficiency, input-oriented ADA, but now we are adding one more thing, which is cost of allocative inefficiency. And what is that cost of allocative inefficiency? Now that would be the last point. So for this Cobb-Douglas case, the cost of allocative inefficiency is going to be, let me just see, so this part. So this looks complicated, but once you estimate the parameters, this is a computation. Okay? It doesn't matter, I told you that you should not be afraid of the functional fault. All you need to do is just plug in the estimates of those things, and then you will get. So this number is going to be giving you the percentage increase in cost because of misallocation. Okay. So in a nutshell, this is what is going on between estimating a production function and estimating a cost function. Okay. No new program is needed, and you get an additional thing if you want to include allocative inefficiency. Okay. Okay. So let me just stop it.
Thank you so much, sir, for your insightful and thought-provoking lecture. We are grateful for the time and knowledge you have shared with us today. So now, as we continue with our program, we have our next expert, Dr. Naresh Kumar. You can give a big hand to him. He's very knowledgeable and expert in the field of research and having expertise of econometrics and time series. So we are very lucky to have him here. So, and he has published many research papers and has attended many national and international conferences. So we are very delighted and excited, sir, to hear you. Thank you so much. I believe that all the participants will get very much benefit from this lecture. Sir will taught us another tool like ARDL and the pound test. We will learn about these tools. So I hope you all are ready.
Yes.
So be enthusiastic and ready to learn.
Hello.
Over to you, sir.
Hello. Okay, go through. Okay, thank you. Good afternoon, everyone. Thank you very much. Uh, Today, I will going to speak on what determines total factor productivity. Should I hold this? Uh, so, today I'm going to speak on this topic: what determines total factor productivity in India. Uh, these empirical investigations. You know, India is a developing country, and because this course is focused on this efficiency and the productivity, so we need to focus that why this productivity is so important, and that's why I choose this topic, this the topic of productivity. And when we talk about this productivity, then you should uh, be clear that this production and the productivity both are separate actual concepts. You can increase the production by let's have some input like land, labor, capital, and entrepreneurship. These are the four basic input actually. You can increase the production, but whether the productivity is there or not, you need to measure it, and it is very much important because you need to, like when we taking the case of India, then I will show the further slide that the productivity is we are performing well in total factor productivity, but there are some loopholes also that we need to focus. So this topic is, you will find it some applied area, some the practical area, and some policy implications also. That what the policy maker at the India level, at the ministry level, they should concern about that. Because this productivity is not only depend on one factor. This total factor productivity that you are considering all the factor inputs. Like in production functions, this the Q. If you can recall this, Q is the output is a function of labor and capital. So you are taking both here actually, and we are when we are considering the more factor inputs like the entrepreneurships and the technology, then it's become more complicated, and you can take more. But now the question is that how you are, or how in what best possible way you are going to utilize your input actually. Like the land, that how like in India, how you are going to utilize your land actually in efficient way, because the economics is there. The study is talking about the efficiency and how efficiently you are actually using your resources. The India is huge resources, but it is up to us that how we are actually converting that input into the output actually. And then the other aspect is labor aspect. So India is a huge population, and we have a demographic dividend also. But the main focus is the skilled labor actually. Whether it's labor, but it is my concern is whether we have skilled labor or not. That is much more important. The technology aspect, the third aspect, the technology. Then we need to have focus on the latest technology, not on the the absolute technology. The fourth aspect is the entrepreneurial aspect. The government of India is making huge efforts for boosting these entrepreneurial activities by 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 training programs, by some of the institutions from IIT and and there are some institutions that like EDII, that is the Entrepreneurial Development Institute of India. They are promoting entrepreneurial education so that our youth, they come forward and just opt for the new ventures, they create new ventures. Okay, so this topic is you will find it. You will find it some more some practical aspect as well as some policy implications. Now you can see when we are talking about the productivity. So the productivity is it's a measure of economic performance. Uh, in economic parameters, we can separate. We can some of the economic measures. There are some economic measures. There are some social measures. Like the GDP is the economic measures, and like the social measure, like the HDI is a social measure, Human Development Index. So the productivity at national level, when we are measuring the productivity, so it is considered as the economic measure. When the productivity can be like in our in policy making purposes, we use this productivity. We can determine or we can calculate productivity in a different by taking different formulas. Right? We can calculate this capital productivity. We can calculate material productivity, labor productivity when you are taking labor only and other things remains constant. And then go to factor productivity by taking all the factor inputs and now, this sometimes it is also known as the multi-factor productivity, as it is generally calculated as the ratio of the aggregate output to the aggregate inputs. Yeah. So every country want to increase the aggregate output actually. So let's assume that in India we want to increase our GDP. So you can say, okay, sir, it is the aggregate output that we need to focus on, and how we can increase aggregate output. That we should use our input in efficient way. That is entire labor capital and entrepreneurships. And sometimes you can say it's a uh, it, and total factor productivity is a key indicator actually for the policymakers uh, at the national levels. And this total factor productivity is actually also used to calculate whether the business is actually cost effective or not. As I saw in the previous lecture, I was talking about that it is the cost that should be focused on. You should minimize the cost, but you should minimize the cost, but you cannot compromise on the quality standards. So you need to focus on the quality parameters also, so that at the international level you can compete. Okay. Then I am just highlighting one concept, that is the Japan Productivity Center concept for on this productivity, that how the developed economy, because India is a developing, still developing, and we need to focus on many parameters. In Japan, actually, one philosophy is there, that is the Kaizen philosophy, and this philosophy is actually focused on continuous improvement. And this continuous improvement, and that is why this Japan Productivity Center, they are actually taking it productivity as it's attitude of mind actually. It's a continuous effort. It is not like that you are just focusing on the machine and you are just technology. It is also our attitude, how we are taking it, whether we are taking it seriously or not. Okay, then they also define this productivity is the continuous efforts in every method and in every techniques. And and you can see they are using the productivity as a faith in human, the progress. Now there are three P's that are also important in the productivity. Before we go in detail, you should learn that these three P's are also very much important for the productivity. That is the prepare, plan, and then performs. Suppose in India, we are talking in our classes that okay, we are in India, we can frame very much good plans, but where is the implementation part? That is much more important, that whether you are going to implement or not. You can draft many schemes, but the implementation is more important, that you are really implement or not. Many schemes are there, like Beti Bachao, Beti Padhao. But okay, we frames very good schemes, but the implementation part is good or not. That you need to check. You need to have a monitoring, because you need to check the efficiency, whether efficiently and effectively we actually implement that scheme or not. Then this 80-20 principle is also very much important. That actually sometimes known as the Pareto principle. That you may be familiar, and if you are not familiar, then you should take into consideration, because it is very much important. And this, according to this principle of productivity, that the 80% of the output is the result of 20% of the input. That means if we focus on the input, then we can increase the output. You can see that 20% of the input are putting 80% of the outputs. And if we can increase the 20 to 30 or 30 to 40, then you can do some dramatical things to the output actually. And I am just putting these. I am just focusing on the aggregate level, India level, that how we can improve the total factor productivity in India. Now, uh, 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 this total factor productivity is a measure of whether how we are efficiently. So in India, then I am just going to in the next slide you'll find some data, and then you will compare the India with some other developing country, whether we are performing or not in science. Like the entrepreneurships. If I am asking you that you are some scholar and the PG students, then how many of you are actually after your PhD you are going to establish new ventures, or you start the new business? So maybe you will. I can just have an experiment, and we can see that whether our youth is actually making some sense toward the creation of the new jobs or not. Because this is much important, because we want to increase aggregate. We want to create aggregate demand as well as increase aggregate supply, because this aggregate supply determine our GDP. This is the and that is the outcome of the production. And the production, if you are increasing the production and if you are taking care of all these factors, that means something you are also taking care of the productivity as well. So this is very important to have a consideration on aggregate demand, aggregate supply, the factor inputs, land, labor, capital, entrepreneurships, and then how you use efficiently. You should take into consideration also. Now, uh, when we are talking about this total factor productivity, you should consider the concept first. Total factor productivity is actually, you can see, is developed by Emerson in 1942 and further elaborated by Stigler in 1947. And actually in 1957, Professor Robert Solow. Have you heard about the Professor Robert Solow, the Nobel laureate? Who propounded one very important concept, that is the solar residuals, and this solar residual is actually capture the impact of technical developments. In suppose you have a PPF, that is the production possibility frontier, and you want to increase that PPF from A point to B point, so that you need to have, whether you need to increase labor and capital, or you need to have some improved technology to shift from one point to another points. So Professor Robert Solow actually propounded the solar residuals, and he actually focused on these technical aspects, because he said that this factor productivity is the result of actually technical developments. And further, Professor Robert Barrow in 1999 proved that the total factor productivity reflects a shift in the production function due to the technological progress. That means he focused on, it is the technology that is more important to shift the productivity A level to B level. That if you want to increase the productivity, like in India, if you want to, suppose you are using handlooms in textile industry, and but nowadays we have the power looms. If you are still using the handlooms, you cannot increase the productivity, and you will left behind in the global scenario. So that means we need to focus on the technological progress. We need latest technology. Otherwise, you are globally incompetitive, or you are nowhere actually. So the Professor Barrow focus on the technological aspects, but there are some contradictory view also in research. Professor Bach in 2001 said that okay, the total factor productivity can be increased without improving technology. So you will find in research, you will find some, the favorable, some contradict. So it is the research that, suppose I want to make research in India, so I have to take some indicators and prove. So next slide, you will find some data, and then I'm just going to prove that okay, these factors are important to increase our total factor productivity. Then in 1967, Professor Johnson argued, and others depend on the economy of scale. This economy of scale is also very much important because the three concepts are there. One is the increasing return to scale, constant return to scale, and decreasing return to scales. Now, now you can see here, this is the generalized form of this Douglas form. Q is the output, and A R L raised to the power alpha, K raised to the power beta. In economics, actually, when we teaching the applied area, we actually discussing these functions, that how you increase this Q. And Q is nothing but Q is the output here. Now, if you are operating, suppose you want to operate at the increasing return to scale, so you need to look at alpha and beta actually. But alpha and beta stand for, these are the elasticities. These are the elasticities. Okay, thank you. So now, am I audible?
Yes, yes.
Okay. Now you can see this here a you can see here this is the Douglas production function. It's a homogeneous function actually. It's a homogeneous. Whether mic is working or not?
चेक कर लेते हैं सर एक बार हाँ, कुछ बोलना सर एक बार
Hello.
नहीं तो माइक नहीं कर रहा काम
So now you can see here if this K is the output, and is the labor, K is the capital, and this alpha and the output elasticity. Alpha, okay, good. I'm comfortable, please. Okay, good. So you can take it if it is possible. Then. Just take. So now you can see this, if alpha plus beta is equal to 1, then it is the constant return to scale, and if alpha plus beta is greater than 1, it is the increasing return to scale. And every firm can economy wants to operate here alpha plus beta is greater than 1 because we want increasing return to scale. Okay, it's a homogeneous functions. So that means if you are taking labor and capital, so you need to focus on both. It's not that, these elasticities are also very much important when you want to increase the production. Now the question is that what are the factors that are actually affecting this total factor productivity? Like in India, if you want to talk about that, how we can increase the productivity. So these are some factors through review literature, there are some factors that I have written here. There are other factors also. So what kind of the factors that are contributing to the total factor productivity? Now, like the gross capital formation, there is the most important factors. In my finding, you will find this factor is the most important. In India, actually, because we are low infrastructures, we need more roads, we need more hospitals, more education institutions, we need more fixed capitals, we need, this gross capital formation is maybe the factors. Then skilled labor, it's not the labor, but I have written here the skilled labor, that And now the government is focusing skilled India, okay, make India skilled India. And every institution, whether it is education and or the technical institutions focus on, okay, please increase but suppose you are MBA and you are a doctorate and if you are not able to, have analytical skills, then not need of that degree actually. So this the skill level is important. Then R&D, the research and development. I'm talking about the India as a whole. So the in India actually the research and development the expenditure as percentage of GDP is very low. So we need to think on research and development also. It's a less than 1% of the GDP. We are
0.69.
0.69. So that means we want to we want to shift from developing to the developed nation. So it is much required factor that we need to increase the share of research and development part. Then governance. There are many indicators, the governance indicators. Uh, okay, shifting on the e-governance is good, but whether we are performing well there, so we need to look. And because we have international, I will show you some, the international statistics also. Then you will realize that okay, we need to think here also because if we want to increase the total factor productivity, because these are the factors that to review literatures. Then human development, the latest human development report we stand at 130, I think 134 position out of I think 179 or 180 countries. So it's need to focus on uh, that also. Then technological development is also, the factor that is much more important nowadays. Okay, we have 4G, 5G, but we should we should the compare these whether this kind of the for example this kind of the internet availability is in rural areas in all areas. I am working since 2010 on the social developments and I have many papers and I find huge disparity in Indian social aspects. So that is also much a big factors. Then that is why I written the societal progress, whether we have really societal progress, because in social progress index we are lagging behind uh, when we are internationally. And you can see the disparity in the at the state level, district level, and some of the states are even in Haryana. You can see some districts are leading and some are lagging behind. Then entrepreneurial development, that is only I will show you some of the factors that you will realize that how many of our graduates are actually interested in starting new ventures, whether they are really suppose you completed your MBA and you want to start your MBA, whether the availability of all the resources are there or not. Then the foreign capital inflows and outflows, FDI and OFDI. Intellectual property is also very much important, whether how many of patent marks, trade secrets, how many files are there, how you like how many patents are filed by the Indians. Okay, then the trade and many other factors. These are some of the factors that are contributing to the total sector productivity. Now, this is the trend you can see, the trend pattern of the total sector productivity in the case of India from, you can see 1999 to 2022, it's an increasing trend, you can see it's a good sign, but we need to focus more and we need more, actually more, uh, you can see, then this is the trend and pattern of total patent granted to India, so it's, you can see it's increasing and then you can see the increasing from 2014 and then and but okay when you compare this data with some other country like China and USA, then you will find okay we are lagging behind and we need to think more. Okay, I'm just showing a few figures to you. Then now you can see this is very important data that the percentage of 18 to 64 populations or age is 18, in between 18 to 64 and who either a nascent entrepreneur, that means an individual who try to establish a new business. So these are the figures and it is zigzag motion you can see and the source is actually global entrepreneurship monitor. Anyone you can visit that site and you can download the data and you can compare the data on India and the other country and you can then you will realize that okay this total factor productivity because the input factor is entrepreneurship also It's not only landed labor and capital, but technology is there, the entrepreneurship is there. Then all the factory input combined with that increase this total factory output. Now, this is the total factor productivity index value comparison with some other countries. Now you can see the Brazil, China, India, Japan, and United States. So these are the data from Federal Reserve's economic data, and you can compare. You can compare with some of the developed country, and because India is a. But one thing you must remember that India is a huge population. You know the labor intensive economy, and the America is a capital intensive economy. We need to focus more on labor actually. If suppose we shift our economy from the labor to the capital, then where our youth actually find the jobs actually. So we need to take into consideration that factor also because we need to employ our youth labor that is, and that why we need to skill them. We need to have courses so impart the technical knowledge. Then it is the index of total factor productivity index. You can see different countries: China, India, Brazil, United States, and Japan. Now I am focusing on some empirical investigation that is by taking the case of India. Now I have taken skill factors so that I can show you this how much this capital formation is important for total factor productivity actually. Now you can see this total factor productivity. This data is actually taken from Federal Reserve Economic Database at constant national level price. So these are the databases internationally we collect and we run some model and then we prove whether these macroeconomic factors are contributing positively or negatively through some some of the econometric models. So this is the dependent variable total factor productivity, whether how what determines that means how the total factor productivity is determined. I'm taking this TRD, that is the trade percentage of GDP from WTI, that is the World Development Indicator database. This database is maintained by World Bank. Then ENT, total entry stage entrepreneurial activities. So this data is also from Global Entrepreneurship Monitor. Then ICT goods imports as a percentage of total imports. ICT stand for, I think everybody is aware about the ICT, information, communication, and technology goods import from percentage of total imports. That is also taken from World Development Indicators. Then GCF, gross capital formation percentage of GDP. So this factor I am focusing on the gross capital formation, that we need more fixed capitals, roads, dams, this and that, and sectors. We need more expenditures, and the PAP, that is the patent filed, total patent or granted by WIPO sites. So that I want to check whether these some of the macro indicators they are whether they are have some impact on this total factor productivity or not. So I am taking this India data from some international databases. Now this is the basic econometric model. You can see here this is the LN, that is the natural logarithm of total factor productivity, and this is the equations. And you can see here the TFP, the total factor productivity, and these are the and all variables are transformed into the natural logarithms. Now, these are the results. These are the actually when you are running a time series model, because the data is actually from 1999 to 2022. So we need to actually stationarize the data. Actually, there should be no stationarity. So you will see at first difference all variables are the stationary and so. Now this is the results of long run ARDL modeling. Now you can see here the R square is the 0.99, 0.99, this is R square 0.99. That means the model is good fit, and Durbin Watson is here to 2.2, that is also very good, and F statistic is also significant. So now you can see here, this is the dependent variable is the total factor productivity, and the coefficients, all coefficients are, you can see here, this gross capital formation, this coefficient is at 10% level of significance. It's contributing positively towards the total factor productivity. So that means, and you can see here the entrepreneurial activities also a positive impact and significant at 5% level of significance. Then ICT is a high, it's 1% around 1% level of significance. So that means all the factors that we have taken, you can see here, we have taken the total factor, we have taken the entrepreneurial activities, the ICT goes in 4% of total imports, gross capital formations, and patents. That means they are contributing positively towards the total factor productivity. So that means we need to think at the policy level. If you are making policy, that means this total factor productivity is not only you are just focusing on the labor or on one aspect and the two aspect, but the many aspects that you need to consider many things. If you at aggregate level you want to increase the aggregate output. Like for example, we want to increase the GDP in India because the government of India is now they're focusing on the 5 trillion government that we should lead toward the 5 trillion. So don't you think that we should use our resources efficiently and that how we can increase the output, the 5 trillion, that means the GDP, the real GDP. How we can increase the output, we should use our input in the more efficient way, or we can use some more technology. We can increase the entrepreneurial activities because the factory input is the entrepreneurship. So these are the results that are actually very important at the policy level, and because that the policy makers will consider it because it's not one and two factors that are important, but it's a large number of factors, macroeconomic factors that are important actually. Uh, these are these are the two figures that the question and question scale test. These are that the model fitness, that the model is good fit. Okay, you can rely on this model, the statistics. Now, now that okay, that means this total factor productivity of any country is not only the labor and capital, but more needs to be taken into considerations. Okay, now the significance of this productivity, that why we need to increase the total factor productivity in India actually. Uh, the first thing is the developed economy vision. Now the India since 1947 we are looking okay we can in 1971 we started the how we should eliminate this poverty, but still the poverty is there. Okay, now we want to have a developed path, but still we are in the developing stage. Now the government is focusing on the achieving 5 trillion economy. So don't you think that means we want to increase the production output? So that means we need to increase our productivity because suppose you have limited input and you want to increase the output, so that means that you need to increase your productivity. Okay. So the first thing is that okay, if India wants to become the developed economy, then we need to focus on this productivity level. The productivity of each and every aspect, the labor. We need skilled labor, efficient labor. If you are the student, if you are, suppose if you are 24 hours, if you are not putting your 14, 15 hours, you can calculate your efficiency every day, that whether you are efficient or not, and whether you are productive or not. Okay. Then the second is the breaking vicious circle of poverty. We cannot break vicious circle of poverty uh, without there is a mechanisms until date the India is in this vicious circle of poverty. We need to break this vicious circle of poverty through aggregate demand and supply mix. So it's a macroeconomics that how we can break, but this productivity is wonderful things. If we can make our youth productive, then we can break this vicious circle of poverty. But this is not a simple thing. The productivity, it is the must thing, the essential things. Then boosting improve quality of life of the farmer as well as the side of the society. Nowadays, you want to improve the if you increase the total factor productivity, that will increase the aggregate output. Aggregate output means that you are increasing. That means your GDP is big, and if your GDP is big, that means you have more per capita and you have more. That means your economically you are your population is your population have a high per capita income, and that means we can say that if you are economically good, uh, that means we can say that you are okay. You can earn your basic, the foods and the clothes and so other things. So we can say that we can just if you want to improve the state of the society, that you need to productivity. Productivity leads to the higher GDP. Actually, in macro sense, then boosting manufacturing competitiveness. This productivity, our GDP, we are more service. Our GDP is more contribution is actually coming from the service sectors. But we need manufacturing. We have huge labor and you need employed actually. So this is boosting the manufacturing community. We need to focus on making in India. We need to export actually. We need to export. Okay. Then demographic dividend. We should focus on the quality of education. If you have huge population but without skill, then what is the need of that population? So the dividend is actually we can cash that dividend by only imparting good health and good education. If you are educated and if you are employed, and then you can create and you can contribute to the economy, and you can, I think you can. That means that this human capital is also much important. It's not a machine. Machines are also good. Technology is good, but the human capital is also much important. Then that's why I am really into SBI and SPI, the human development aspect, the social progress aspect. If suppose in India, one region is developed, another is lagging behind. Like the Bihar is, the ones we are talking about the Bimaru states, or the Bihar is the number one. But like so say in Haryana, one district is very low and other districts are very high. So when you disparity, you will find social disparities, and you will find some other kind of the problems you will find in the society, and that will lead to lower the GDP. Actually. Okay, then this increase aggregate demand and aggregate supply. Uh, but in India, uh, now there are some challenges to improve. It's not easy at country level. Like in India, you want to at the policy. Suppose you are at the ministry level and you want to improve, so you at least you should have some point that okay, these are the points that I should look into consideration. Like like the capital market reforms done in India, labor laws, the farmer laws, and if somebody is making good law, then the implementation is you will find it difficult, and if suppose the implementation, then execution and some you will find a delays. Maybe that are the bureaucratic delays and uh, what you can say. There are less health expenditure. When the expenditure, the government expenditure part is taking care, you are considered. Then you will find, in India, we are the health expenditure from the health expenditure as a percentage of GDP, you will find it very low. So we need more health infrastructure. Actually, we need more aims, we need more PGIs. It's not the private sector that will increase on everything, because the good health is if our labor force have good health and the good everything, they can contribute more to the national GDP. Okay, good output. Then education expenditure, they're in the top 100, I think QS ranking, and the quality of everybody wants the quality education. If suppose you have degree, you have MBA, and suppose you have doctorate degree, you will find no jobs. Then what is the reason? Yeah, that you should ask yourself. So it's a good quality of education, and that means the government should. Okay, suppose we have nowadays we have more than 20 IIMs and 20 IITs. Don't you think that the India is a huge population country, and you need more IITs and more IIMs and more facilities? Okay, it's not either 20 or 22. It's not when we compare the population actually. That means the educational institution must be based on the number of youth, the population, the size, the strata. Okay, like in Haryana, we have one in Rohtak, okay. But I think the total intake will be how much? Less than 500. Okay, IIT Delhi. How many you that can? So we need to think on this aspect that we need a huge population. Everybody, suppose A, B, C are want to be some medical professionals. There's some there must be some seat for the intelligent students. We need to think on this aspect. Then jobless growth. We have growth, but there are some written, the analysis paper that India is actually having a growth, but jobless growth. Okay, huge unemployment, and and where is somebody said that okay, where is this unemployment, where is the rate? Okay, we need to think also that we should have the fair and a transparent look on the database, how much unemployment is there, and how many the graduates are actually looking for the jobs, how many PGs are looking for the jobs, how many doctors are looking for the jobs, and on that basis the government can frame some policies. Okay, then this female empowerment is the participant in the labor force. In India, this female empowerment is empowering the women. Okay, politically, economically, socially. Whether they are really empowered or not, it's a big question. Okay, it's a question of research. Then you can think that whether we are really empowered or not, because in the labor participation, if they are not participating, so that means we are lacking in the output actually, because this indicator is the very important the labor how much percentage the women are in the labor participations. Then quality at small medium enterprises, that is also much important because they are contributing a huge in the GDP exports. In the export as a percentage of GDP, and that we need to think that so that we can think on the quality aspect so that we can make some quality products and services and then export to the other countries. Then lower investment in R&D is less than 7%, 0.7% of the GDP. Then this is also what important, that is the fiscal deficit. We have a huge fiscal deficit, and then we should think and on the non-productive expenditures actually. We need to think of the expenditures should be productive in nature. We should focus more on uh, the the productive expenditures on like more roads, the hospitals, the infrastructure, the railways. Okay, the good institutions for the youth, so that we can convert our human capital to the scale capital. And that is though the fiscal deficit is good if it is if all of the expenditure are productive in nature, but in India you will find a lot of expenditure is non productive in nature actually. Then the governance and corruption issue, you can see some of the data in the morning. I'll take this data in Transparency International 2002-3 Corruption Perception Index. That means out of 180 countries, you will find 0 means highly corrupt and 100 means very clean. So India scored 39 actually. These are the international reports. You can see if 0 means highly corrupt and 100 means very clean. So we are India score the value of for India is 39. So that means we need to think on the India rank 93 out of 490 countries in the perception index, and that means the rank is 93. Then HDI score, Human Development Index score, that is near to 1 is much better. It's a 0 to 1. HDI index is from 0 to 1. The latest value for India is 0.644. That means in 2022 positioning at 134. That means that India is nowadays at 134 position in Human Development Index, and that is comprising of 3 indicators. I think health, expenditure, education, and school per capita income. I think the 3 indicators that we need to focus. That is, it's not easy to increase the total factor productivity in India. We need to think of the, so these parameters also. And these are not Indian reports. These are the UN reports, some international reports, and I have taken the data mostly from the international reports, World Bank and WIPO and many others. And one is the legal hurdles. You know, that in India you will find uh, uh, we need legal reforms at all levels. It is not the lower judiciary, but it is the medium and the high courts and the Supreme Court also. We need reforms such as so that we can have a transparent systems, we can have a job-oriented systems, uh, so that everyone finds the good health, good education, and can participate in contributing to the aggregate output. So that means this discussion is actually that how we can increase the total factor productivity. This is not only the labor, it is not only the capital, but it is something more that is much required. It is the technology, entrepreneurship, good governance, expenditure from the government, so it, the everything at a macro level. These are the factors that must be taken consideration at the policy level, so that we can have in India we can have a dream India, we can have India that can we can say at the path where we really want India, that must be at that level of the development. So this is from my side. If you have any question regarding the total factor productivity and why India should focus on some of the issues, macroeconomic issues, because nowadays we are in a global economy, global society, so we need to uh, we need to think actually internationally. We are not actually like in education. Uh, we need to increase the efficiency and the productivity, and that's why we are always the productivity of the student, the productivity of the teacher. Okay, so these efficiency and the productivity measures should be in all the sectors. And when we are talking about the India, so that means the we all uh, as I am an economic scholar, so my concern is about that how we can increase our aggregate output, how we can increase our real GDP so that everyone have a good per capita income and can contribute to the society. Because it's not the number that is much important, it is the society, it is the inclusion of the society that is much more important. Okay, that means the labor, we have a huge labor force in, you practically you can see in every, at labor shop in the district. You will find a lot, but we need more skilled labor actually. We have a huge graduates, the population, the doctorate, master degree holders, the graduates. We need the skilled graduate actually, who have skill. You will, so my point of concern is that it is a time to think at root level actually. Uh, Good quality education, good health, transparency, and many other macroeconomic indicators, so that we can achieve a Viksit Bharat Sardabar. Thank you very much, Jai Hind, Jai Bharat.
Thank you so much, sir, for the wonderful session. And it has been an absolute privilege to have had the opportunity to learn from you. I'm sure all of us have gained invaluable insight and knowledge from this session. Now I would like to request Dr. Subal, Professor Subal, to honor and felicitate our expert with an memento. Please give a big hand. Thank you so much, everyone, for the patient listening.
Okay, thank you very much.